Hello guys, this is Prime Concept. You're welcome once again to my channel. In this video, I want to look at analyzing different questions under the vector differential. So we'll be solving random questions, different questions that pertains vector differential. So we'll solve up to 10, let's say 5 questions as time permits us. So I want you to do well to stick with me in this video. Some of these questions are exam questions for some universities, which is very important in your physics 101, say SUMAS, say ESUT, UNN, and so on, UNIZIK. So this is like your CA test problem. So let's see how to solve them. The first one we have says, find the direction derivative of this. This is a scalar. Because how do we know that this is a scalar? It does not carry directions I, J, or K. It's a scalar. So we say find the direction derivative of this at the point this. So in the direction of this. So it's very simple. The direction derivative simply means you're multiplying the gradient. Remember, gradient of this is denoted as this. So it means that we're finding the dot product of the gradient and the unit vector of this. So this is what we want to do, and we have answered this question. So first thing first, let's start with finding the gradient. Let's start by finding the gradient, which is just this. Now this gradient is given by the formula I d phi dx plus j d phi dy plus k d phi the what? The z. So I'm going to solve them one after the other, one at a time. So I would find the phi dx. I would solve this. Now this simply means we are differentiating this scalar with respect to x. So remember, this is a partial derivative. So if I differentiate x in this place, I would have 1. So I'll be left with 1 times 4, which is 4z cubed. So I have 4z cubed. Now if I differentiate x in this part, I have 2 times minus 3, which is minus 6. Then x. You subtract 1 from this power, you have 1, which you don't have to write. Then you write back your what? Y squared. So very quickly, I'm going to substitute this point. So wherever I see x, I'll put 2. Wherever I see y, this, and z, this. So I have 4 into z, which is 2 raised to power 3 minus 6 into x, 2, then y minus 1 squared. So solving this, 2 to power 3 is 8 times this is 24. Yes. So we have 24, then minus, okay, 24 minus 12 will just give me 12. 32, okay, minus 12 will give me 20. So this is going to be 20. Now I've found this. The next thing I want to find is the phi dy. So I want to get the other part, which is this. So I'm going to differentiate this whole thing with respect to y. So if I look at this first part, you notice there's no y. So this part is 0. So if I come to this part, I have 2 times minus 3, which is minus 6. Then I have x squared. Then I have y to power 1, which I don't have to write. So substituting, I have minus 6 into x, which is 2 squared, then y minus 1. So if I solve this, I have 2 to power 2, 4. 4 times 6 is 24. Minus minus would go, so I have 24. Then finally, I want to get the phi, the z. So it means I'll be differentiating with respect to z. So if I differentiate this part, I have 3 times 4, which is 12x. Then z to power 2. What it means is that when you use 3 to multiply 4, you subtract 1 from 3, then you have power 2. Now, the same way, if I come to this part, there is no z, means this part is 0. So this is just what I have. Substituting, I have 12 into x, which is 2, into z, which is 2, all squared. So solving this would give me 4 times 2 is 8. 8 times this is 80. 8 times 2 is 16. Write 6, carry 1. 8 times 1, 8, plus 1, 9. So this is 96. So I've found these three things. So what it means is that my gradient is going to be, using this formula, is going to be this, which I've gotten as 20. So I have 20 times I is 20I. Then for this part, I would have this, which I got as 24 plus 24J. Then for the last part is plus 96K. So this is what I have as the gradient. Then the next thing I want to do, remember, this is the aim. This is what we want to get. So I need to find the unit vector, because this is actually what I'm calling A. So I need to find the unit vector. If A is equal to 2I given to us minus 3J plus 6K, it means that the unit vector for A is going to be A over the magnitude of A. I need to find this. Now let's do it together. For you to find this, first you need to find the magnitude of A. Magnitude of A is the square root of 2 squared plus minus 3 squared plus 6 squared. So this is it. So that when I solve this, let's see, I have 4 plus 9 plus 36. 4 plus 9 plus 36. I think that should be 49. Let's see. That's 49. So I have square root of 49, which is equal to what? 7. So it means that the magnitude of A is 7. So I'll drop this part. So what do I have now? I have that the unit vector, this is called the unit vector. This is a unit vector. So the unit vector A is going to be A, which is 2I minus 3J plus 6K, all over its magnitude, which is 7. So this is what I have. Finally, to get my answer, this is what I'm looking for. So I'm going to get the dot product of the gradient and the unit vector. So let's write it. What is our gradient? Our gradient we got to be 20I plus 24J plus 96K. I'm going to dot this with our unit vector. So this will be dotting with, I don't have space, but let me write it. This will be dotting with 2 over 7I minus 3 over 7J plus 6 over 7K. I'm dotting both of them. So if I find that dot, let's see what we have. Obviously going to be a scalar. So what I'm going to do is I'm going to say 20 times 2 over 7. For dot product, you only multiply those ones in same direction, I. So I'll just say 20 times 2 over 7, which is 40 over 7. I'll say 24 times minus 3 over 7. Let's see. 24 times minus 3 over 7, which is going to give me minus 72 over 7. Then I'll say 96 times 6. 96 times 6 is plus 576 over 7. So I'm going to add them up now. I'm going to add them up. So if I add them up, I would have this plus minus 72 plus 40. So I have 544 over 7. So this is what I have as the answer to this question. So I want to quickly jump to number 2, the next question. All right, now I want to solve the second one. This is very simple. They said let G equals this, compute this. Of course, from what we explained in our previous video, you should know that this result would always be 1 and 0, would always vanish. The result would always be 0. But they want us to show that using the vectors they have given to us. So we're going to do it gradually. First, we want to find the core of G. When we get this, then we'll get the dot of it. So to do this, we recall that we usually use the determinant I, J, and K. Then we use our differential, the X, the Y, the Z. Then I have G of X, G of Y, and then G of Z. So this is what I have. So using our determinant method, we have I outside our bracket. We want to find determinant of this matrix. You close this part, you close this part. You'll be left with this times this, which is d dy g of z minus this times this, which is d z g of y. This is what you have. And the next is for j. Remember, this is always plus, minus, and what? Plus. So for j, I have minus j into, I'll close this part, close this part. So therefore, I'll have this times this, which is d of gz dx. Then this times this, which is minus d of gx dz. And finally, I'll have plus k. So if I close this part for k and close this unit vector, I would have this times this, so which is d dx of g of y minus this times this, d dy of g of x. So this is what I'll have, which I'm going to have to do gradually. So very quickly, I'll find dg of z dy. So to find this, it means I'm differentiating g of z. G of z is the part that is associated with k. So, and you see it's 0. So it means that this is 0. So secondly, I'll have to differentiate d of gy with respect to z. So I'll look for gy. Gy is the part associated with j, which is this. And I'm differentiating it with respect to z. Because there is no z in this part, it means it is also going to be what? 0. Then I'll look for dg of z with respect to x. Now, gz is this part, which is still 0. Then I'll look for dg of x with respect to z. So g of x is what I'm going to look for. G of x is this part, but I'm differentiating with respect to z. And there is no z on this side, so it is also what? 0. Then I'm going to look for dg of y with respect to x. Now g of y is this, right? And I'm differentiating with respect to x. So when you differentiate x, what will it give you? 1. Then I'm going to look for dg, which, okay, this now, dg of x with respect to what? Y. Let's see g of x. G of x is this. If I differentiate this, I would get minus 1, because I'm differentiating with respect to y, and I have minus y. When you differentiate minus y, you get minus 1. So to substitute, I have that my core of g is going to be this. Remember, there is I outside, so I have I outside. What is dg of z? This part I got as 0, so I have 0 minus. This other part I also got as 0. Then I have minus j into this part I got as 0 also. Then minus this part I got as 0 also. Then plus k. This part I got as what? 1. Then minus this other part I got as minus 1. So I would say minus 1. Right? So that when I solve this, I'll quickly notice that 0 minus 0 is 0. 0 times this would go. 0 minus 0 is 0. 0 times this would go. Then I have minus times minus is plus. So 1 plus 1 is 2. So I have 2k. So my answer here is 2k. 2k. But is this all I want to do? Of course not. because I already know the expectation. I expect that my final answer should be 0. So I'm going to rub this part so I can have space. So while you're watching these videos, try to be copying them out, right? I'm going to rub this part. So I'll rub this. So what I'm trying to find is this. So I have this dot this cross this. This is what I'm trying to find. So what is my divergence? Divergence is simply this, the x, g of x, plus this, the y, g of y, plus this, the z, g of z. So that is what this thing would be now. All right, the divergence. I shouldn't be using g of again. I don't know a better way to write it. So let's just call this whole thing, let's call it a new vector b. So if it is a new vector b, then I'll be saying b of x, b of y, and then b of what? Z. So I'm calling core of g, I'm calling it to be a new vector b. So it means that I'll be saying b of x, b of y, and b of z, and so on. Now, what is b of x? If you check, there is no I part in this. That is to say b is actually 2k, and there is no I part there. So it means that b of x is 0. So this first part is 0. B of y, there is no j part here. So it means b of y is 0, so plus 0. Then b of z is actually what now? Is just 2. Only 2. Remember, 2 is a constant. So when you differentiate with respect, when you differentiate this, differentiate a constant with respect to any variable, it's also going to be what? 0. So this is going to be 0. So at the end of the day, you'd have what? 0. Your answer should be what? 0. Remember, when you differentiate, 2 is a constant, so 2 should give you 0. So this is 0, and we have said that it would always be what? 0. So they just wanted us to prove this using the question given to us. So let's take question number 3. Now we have another question again to tackle. They said find the constants a, b, and c such that the vector a equals this becomes irrotational. The condition for a vector to be irrotational is that the core of that vector would vanish. The core would be 0. So that is the condition for a vector to be irrotational. So still using our matrix form, because we're going to look for core and set it, equate it to 0, so that we can find the values of a, b, and what. See, that is what the question wants us to do. Now, very quickly, it's going to be a bit long, but we're going to go through the process. So we have that our core of A is the matrix I, J, K, D, the X, D, the Y, D, the Z, AX, AY, AZ. This is what we have. Now, we need to find, I'm going to go straight because we have been doing this already. So I'm going to go straight. I need to find the y of AZ. I need to find it. So I'll find all what I would need to get the determinant of this matrix. And D, so which is just this. So I'm going to find this. I'm differentiating AZ. What is AZ? AZ is this part connected to K. So I'm differentiating it with respect to Y. So if I differentiate this, is 0, because this does not contain Y, so it's 0. If I differentiate this that contains Y, I have C. So I have C. If I differentiate this part does not contain Y, it is 0. So next, I want to find DAY with respect to what? Z. That is to say this. So let's quickly do it. So I'll look for AY. AY is the part connected to J. I'm differentiating with respect to Z. If I differentiate this first part, it is 0. Differentiate this, it is 0. Differentiate this, it is what? Minus 1. Then next, I'll go for J. So for this and for this, I'll be differentiating d of az with respect to x. So let's find this. So az is actually this, differentiating with respect to x. If I differentiate this first part, I will get 4 because it has x. So if I differentiate this is 0, differentiate this is 0. Then next I want to get, remember I have this, so I'm doing this, then I'm doing this. So I want to get d of ax with respect to z. Now, with respect to ax is this, with respect to z, this would be 0, this would be 0, then this would be a. If you differentiate z is 1, 1 times a is a. So that would be a. Now, finally, I'll go for k. If I cover this, I'll have d of ay with respect to what? X. So if I do this, ay is this part. With respect to x, this would give me b. This would be 0, this would be 0. Then I'll do d of ax with respect to what? Y. So what is my ax? This is ax. With respect to y, this is 0. This is minus 2. Minus 2. This part is what? 0. So this is what I have. So very quickly, my answer, I'm going to put it, the determinant of this matrix, which is this, the determinant of the matrix, I'm going to be writing, is going to be I into, I will go straight. For I will close this part, So I'll have this times this, which is daz times this, which is c. So I have c minus, then I will go this times this, day dz, which is minus 1. When it comes here, it becomes plus 1. Then I will go to minus j. Do the same thing. Now for j, I'll close this part and then close this part. So I'll have this times this. Az with respect to x is going to be 4. Then minus, remember I'm closing this and I'm closing this. So this is az with respect to x. Then I'll have this, which is ax with respect to z. Ax with respect to z, so which is a. So I have a. Then finally I have plus k. I'll close again. Okay, this is k and this is this. So I have ay with respect to x. Ay with respect to x is b. Then I'll say minus. This is the then. I'll do this times this. That is to say ax with respect to y. Ax with respect to y. This is minus 2. When it comes here, it becomes plus 2. So this is what I have. So if I should resolve this, so it will still, okay, it will remain that way. Cannot really do anything. Now they said we should find the values of a, b, and c such that this vector vanishes or this vector becomes irrotational. And we mentioned that for a vector to be irrotational, it means that the core of that vector is what? 0. When you say the core of a vector is 0, what it means is that the component of I is 0, the component of j is 0, the component of k is what? 0. So what it means is that we're going to separately equate each of these components to 0. So equating this first part to 0, I have c plus 1 equal to 0, which would imply that c is equal to minus 1. Equating this other part, remember this is minus, so I have minus into 4 minus a equals 0. This minus would go, right? Of course, you should know if you multiply through by minus, this minus will go. So I'll just say 4 minus a is 0, which would imply that 4 is equal to a, or a is equal to what? 4. Then finally for b, I would have this part equating it to 0. So I have b plus 2 equal to 0, which would imply that b equals minus 2. So my values of a, b, and c, respectively be There's my A, would respectively be 4, comma, minus 2, and what is my C? And minus 1. So these are the values of A, B, and C respectively. So I believe this is also very clear to you. Let's see if we can take one more question before we call it an end for this video. Alright, now I want to close this video with a simple one under vectors. This is still part of the assignment we are still solving, or the CA problems we are still solving. Now we have given a vector A equals this. Find the value of B. So we have an unknown. Find the value of B in a vector B, which is this 4i minus bj. So B is an unknown. We're finding the value of B in the vector B such that A and B are perpendicular. Very simple application of vectors. Now, one thing I want you to know is that if two vectors are perpendicular, then their dot product is 0. So A dot B will be equal to 0 if two vectors are what? Perpendicular. So using this idea, I have that A dot B. I want to find A dot B. I would equate it to 0 at the end of the day, and then I'll find B. So what is my A? My A is 2i plus 5j plus 4k. So this dot my B. My B is 4i minus bj plus 5k. So I want to find their dot product. Remember, for dot product, you multiply only those ones in the same direction. So I'll just say 2 times 4 will give me what? 8. Remember, I times I is 1. So I have just 8. I'll do the same thing. 5 times minus b to give me minus 5b. Remember, j dot j is 1, so I don't have to write j again. So 4 times 5 is what? 20. So what I've just gotten is my A dot B. So let's quickly add it up. So I have 8 plus 20 is 28 minus 5b. Remember that for the two vectors to be perpendicular simply means their dot product is 0. So it means I'm going to equate this to 0. So that I have 28 equals 5b, or I can say 5b equals 28. To find b, I'll divide both sides by 5. So I'll have by 5, this would go, then b becomes 28 divided by what? 5, and this is my answer. Now this is going to be the last question for this video. In subsequent videos, I'll be solving more. I still have a lot of problems which I'll be solving. I don't want this video to be too long. That's why I'm stopping it here. So if you are really enjoying what I'm doing and you have not subscribed, please do well to hit the subscribe button. That is your own way of showing support and telling me to move on with what I'm doing. Do well to share the video with your friends, your different class groups. Tell them it is prime concept. They need to learn all the concepts from these videos. You can check out my channel. You would find other videos on vectors, mass, indices, logarithm, unit, and so many other topics on my channel. So do well to drop your comment and the next area you would want me to handle. Thanks for always following Prime Concept.